This video is about interpreting quadratic functions. So over the course of this video, I'm going to be showing you a number of quadratic functions that are already graphed, and then we're going to use those to answer some questions about the functions in question. What I would suggest that you do to start off is to actually start by taking each of these functions and graphing them on separate diagrams. Make sure to label them clearly so that you know which one is f of x, which is g of x, which is h of x, and so on. By doing this, you'll be able to follow along with what I'm doing in my solutions much more easily, and you'll get much more benefit from this video overall. So pause the video now, draw these 5 functions, and then we'll look at some questions relating to them. It's important to emphasize that no pair of graphs are going to be identical, so my graph is going to be a little bit different from your graph. We're going to be using our graphs to estimate our solutions, so it's possible that my solutions might be a little bit different from yours, but we should be quite close, and the more accurately we draw our graphs, the more accurate our answers are going to be. So take care as you graph. So now that we have our graphs, we're going to look at how to find the roots of the quadratics. First, we need to know what we mean when we say find the roots of the quadratic. And this question may be phrased in a variety of ways. So we might be asked to find the roots, or we might be asked to find x when f of x equals to 0, or we might be asked to find where the quadratic cuts the x-axis or crosses the x-axis. So first of all, let's look at this question for the f of x graph. So this is the graph that you should have your f of x. And in this case, we can see the roots quite clearly. It's going through the x-axis at 0 and 4. So to write down our solution, we would simply note those two values, x equals 0, x equals 4. Here's the g of x function. Have a look yourself for a moment. Can you identify the roots? This time the roots are -2 and 1. Here's the h of x function. Again, take a moment to identify its roots. In this case, the roots are -1 and 1.5. Here I have my j of x function. What are its roots? These are slightly less obvious than the previous ones because the previous roots all landed in nice whole number positions, or like in the last example on 1.5 fairly directly. Here we can see that our roots are located just before -2.5 and just before 1. So we're just trying to estimate them as accurately as we can. And for my graph, they look like they're at about -2.4 and 0.8. Finally, we have our k of x function. Again, identify its roots as accurately as you can. -1 is an obvious root. And over here, just before 1.5, so I'm going to estimate 1.4. Notice that this quadratic looks different to all the rest. It's n-shaped, not u-shaped. That's because of the minus in front of the x squared. Next, let's look at finding the y-intercept. Another way of phrasing this is, where does the function cut the y-axis? While we will be using the graphs to interpret these answers, it's important to note that we always get a big clue about the y-intercept, because it's always going to be the value of the constant at the end of the quadratic. Let's look through each of our functions in turn. So here's the f of x graph, and there's my y-axis, and I can see quite clearly that the function is passing through the y-axis at 0. And this isn't hugely surprising, because if I look at my quadratic function down here, the constant at the end, well, there isn't one written down, but I could write a +0 at the end. So in this case, the y-intercept is y equals 0. What about g of x? Well, we can see quite clearly that it passes through the y-axis at -2. And just to note, that does match up with the function. Here we have our h of x function. What's its y-intercept? It passes through the y-axis at -3. So the y-intercept is y equals -3. And again, we can see that it agrees with the function that's written down for h of x. Here's the j of x function. What's its y-intercept? We can see it's y equals -4. Again, this agrees with what we have in our function. What about k of x? What's its y-intercept? It's going through the y-axis at 3. So So my answer is y equals 3, and again, this matches up what I have in the function. Notice that I've given all my y-intercepts as y values. If they ask you for the point at which the curve intercepts the y-axis, well then just make sure to write it as a point, in which case you'd write it in this format. And of course, because it's a y-intercept value, the point is on the y-axis, all the x values are 0. Next, we're going to look at finding the minimum or maximum value or point on the function. This can also be called the turning point of the function. If it just asks us for the value, then they mean the y value. If they ask us for the full point, well then we give them the full point. For each of our graphs, I'll show you how to write the answer for the value and for the full point. Let's start by looking at f of x. First of all, let's locate its minimum point. It's located just here, at the bottom of the curve. To get the minimum value, I simply draw a line straight across to the y-axis, and I can see that I'd land on -4. So the minimum value for f of x in this case is y equals -4. The minimum point is the actual point that I've marked itself. In this case, it's 2 minus 4. Next, let's look at g of x. First of all, let's find the minimum point. In this case, it's located here. To get the minimum value, go straight across to the y-axis. Now this time I'm not landing on an exact value, on a whole number, so I need to use my common sense. While I'm not quite as far down as -2.5, I would say I'm at about -2.3. Again, read it as accurately as you can from your own graph. The minimum point is the full point. In this case, approximately 0.5 minus 2.3. Here we have h of x. Again, let's try and identify our minimum point so we can find the value and then the point. This time my minimum point looks like it's around about here. And again, I have to just be as accurate as I can with my own diagram. I'm not far below -3. For my graph, I read it at about -3.3. The minimum point this time is about 0.3 minus 3.3. Don't worry if you don't get exactly these solutions on your own graph. As long as they're quite close, you're okay. You are allowed a little bit of leeway in your solutions in an exam. Next, we have j of x. Take a moment to find its lowest point. I would locate it about here. So again, let's find the minimum value first of all, which is just the y value. And it's just below -5. And I would say for my graph, it's about -5.2. The point in this case is approximately -0.7 minus 5.2. Finally, we come to k of x. Do you think it's appropriate in this case to look for a minimum value? Well, when I look at this curve, I don't see a lowest turning point. Instead, because it's an N-shaped curve, I see a highest turning point. So for a curve like this, I'd be asked to find the maximum value or the maximum point. So let's take a moment to find that on the graph. And it's located around about here. My y value is just above 3. I'm going to say about 3.1. And the maximum point is approximately 0.33.1. Again, don't forget, you'll be allowed a little bit of wiggle room. The next type of question gets asked occasionally. Find the equation of the axis of symmetry of the function. I've left the same page up here with the max and min values and max and min points because it's related to how we find the equation of the axis of symmetry. Here we see the f of x function again. You can see here that the minimum point is marked in green. The axis of symmetry of this function travels right down through this point. And this axis is a vertical line. So to write down the axis of symmetry, all I'll need to do each time is write down x equals and the value that I pass through on the x-axis. This is the same as the x part of the point for the minimum or maximum point. So in the case of f of x here, I can see that the minimum point is the point 2 minus 4. So a line down the middle of the function would pass through 2 on the x-axis. That's the x part of the minimum point. So the axis of symmetry can be written as x equals 2. And this is the equation of the axis of symmetry of this function. Next we have g of x. I've actually spotted a tiny error from the last set of questions. Notice there that the minimum point is to the left of the y-axis. So this should be what, do you think? This should be a minus 0.5. Sorry about that. So in this case, our minimum point is here. And if I was to draw a line through it vertically, it would go through that minus 0.5 on the x-axis. So x equals minus 0.5 is the axis of symmetry. H of x, we saw had a minimum point at 0.3 minus 3.3. Again, just take the x part of the point. X equals 0.3 is the axis of symmetry. Here's j of x. Here's its minimum point. We note that point is minus 0.7 minus 5.2. We take the x part of that point to get the axis of symmetry. So in this case, the axis of symmetry has an equation x equals minus 0.7. And finally, we have k of x. It had a maximum point, but the same concept still applies. The point was here at the point 0.33.1. So the axis of symmetry runs through x equals 0.3. And so that's the equation of the axis of symmetry in that case.